Now this is probably a question that you've been asking yourself. So water flows 8.854 meters per second down a 1.59 centimeter diameter hose, right? What time will it take to fill a circular kiddie pool that is 1.75 meters in diameter to a depth of 37 centimeters? So basically the area of that hose, right? Whatever that cross-sectional area is, right? Times whatever that velocity is going to equal whatever that volume is of the kiddie pool, right? We got this kiddie pool. Right, whatever that volume is divided by time, right? Because this is going to be cubic meters per second. This is our change in volume over time, right? So ultimately the time is going to be whatever the volume of this kiddie pool is, right? Divided by that flow rate, okay? So let's figure out the volume of this thing. The volume is going to be pi r squared times h, right? Because it's the area of the top times the height, right? So let's figure that out. That's going to be pi times 1.75, and that's meters divided by 2 squared, and then times 37.37. Okay, here we go. I bet it's not even a cubic meter, but it might be. Okay, so pi times parentheses 1.75 divided by 2 and parentheses squared times 0.37. And that is 0.88995 cubic meters. So our volume is 0.88995 cubic meters. Not even a cubic meter. That's a lot of stuff. That's not my answer though. Let's see. And then let's figure out our volume flow rate. So our volume flow rate is the area of the hose times the velocity, right? So it's, again, it's going to be pi r squared times our velocity. Right, so pi times, and then 1.59, 0.0159 times our velocity, right? Meters per second. All right, I can do this. So pi times 0.159 divided by 2 squared times 0.854. All right, that is not very many cubic meters per second. So this equals 1.6956 times 10 to the minus 4th cubic meters per second. All right, and now we're ready to do the big thing. Here's the big thing, right? So 1.6956 times 10 to the minus 4th cubic meters per second is equal to this much cubic meters. Divided by time. So obviously it's going to be this divided by this. So I'm going to take the first number I calculated, divide by the second number I calculated, and I get the t is equal to 5248.38 seconds. With 3 sig figs we'd have to say 5250. All right, so these ones are just, the water flowing down the pipe is the cubic meters per second, and then you're gonna have time, and then maybe you'll figure out a change in volume or something like that. Okay, but pretty basic, I feel like.